So these sequences will be needed for further studies in series. But let's see the behavior of this sequence when R changes.
Okay.
So let me just say we want to determine the behavior you get that now? Or
Okay.
we want to determine for which value, or want to determine the value of R at which the sequence R raised to power n converges. Is that clear?
Yes, sir.
So we want to see at what value of R will it converge? At what value of R will it diverge? So we'll do that by taking limit. So let me just give you the summary. Then we'll now see the behavior in some sequences. Limit of R raised to power n as n tends to infinity equals infinity if R is greater than 1. It will be infinity if R is greater than 1.
Okay.
Let's check it. Don't forget that infinity is relatively a large number. So I want you to take your calculator. Do you have your calculator with you?
Yes, I do.
Okay. Now, let's assume you have said that if R is greater than 1,
Yeah.
it will be...
If R is greater than 1, infinity. It should be infinity if R is greater than 1.
Yes, if R is greater than 1, it will be infinity. So I want you to check it. Suppose R is 2 and n
Okay.
is 10, for instance. R is 2, n is 10. So that means we are going to do 2 raised to power 10. So what do you get? If you do 2 raised to power 10.
Okay. Yes, I have 2 raised to power 10.
Yes, equal to that what?
Is 1024.
Okay. Now take R to the 3 as do 3 raised to power 10.
Okay. 59,049.
49. We have do 4 raised to power 10.
Ooh, that's
That's 1,048,576.
1,48,576.
So you can see that as R is increasing, the
Yes.
value of R raised to power n is increasing.
Oh, yes.
So that's the meaning of tending to infinity. Hope that is clear. Okay. Now it's going to be 0 if R or if absolute value of R is less than 1. It's going to be 0 if absolute value of R is less than 1. Let's take value that will be less than 1. Let's take 1/2, for instance. Now, say 1/2 raised to power 10.
Over 2 is about 10. Ooh. 9.766.
Times 10 raised to power minus 4.
Yes.
Okay. What does that mean? It means 0.0009765. All right?
Yes, sir.
Okay. Oh, yeah, take R to be 1/3. You know, 1/3 is less than 1/2.
1/2.
Okay.
Okay.
Yeah, take R to be 1/3.
Oh, is this? Oh, sorry, I did it wrong, sir.
You did what?
1/. It's 1.69
35 times 10 raised to power minus
times
5.
10 raised to power minus 5. Yes.
So you can see the value is reducing.
Yes.
Okay.
Yes, sir.
Now
10 raised to power minus 5.
take R to be 0.2. So you are going to do 0.2 raised to power 10.
2 raised to 10. Okay. Oh, that's 1.024
times 10 raised to power minus 7.
So,
So you can see that it's
yes, sir.
approaching 0.
Smaller.
So in
Yeah.
that sense, you say that the limit is 0. Now the limit will be 1 if R equals 1. If R equals 1. 1 raised to power any number is 1. All right? If you say 1 raised to power 10, it's
Yes,
going to
sir.
be 1 because it means 1
One time,
times
sometime.
in 10 places. So if R is 1, then the limit of R raised to power n, as n approaches infinity, will be 1. Now, let's now look at when R is less than minus 1. We say that does not exist. If R is less or equal to minus 1, the limit does not exist because it will be oscillating. It will be oscillating. It will be oscillating in the sense that if the value you are going to get if n is odd will be different from when n is even.
Yeah.
Do you understand that now? So in that sense, you say that the limit does not exist. So that's the behavior of that sequence. Now, we can now conclude that our conclusion will not, don't forget what we are trying to investigate is to know the value of R at which it will converge. Do you get that now? So we can now conclude that hence AN, the sequence AN, and of course, you know that AN is R raised to power n. Converges when R equals 1 and when absolute value of R is less than 1. So in other words, we are looking at where you have 0 and 1. Hope that makes sense to you.
Okay. R and R convergent. when R equals to 1 and
and absolute value of
absolute
R
value of R
is less than
is
1.
less than 1. So when R is 1 or 0.
Yes.
Sorry,
No, the limit
when
is the limit that is
limit is,
0 or
yeah,
1.
yeah,
But the value of R to achieve that is when the absolute value of R is less than 1. In other words, you take positive values that are less than 1
yeah.
and you evaluate the limit, it will be 0, convergence.
Okay.
When R is 1, evaluate the limit is 1, it converges. So when R is greater than 1, the sequence will diverge because the limit tends to infinity. And also when R is less than or equal to minus 1, the limit does not exist. Hence, the limit diverges when R takes that value. Understood?
Yes, sir.
So you can add that to it. You can also, okay, I said hence, sequence of AN is converges when R is 1 and this. Also, or let me say and, diverges when R is greater than 1 and R is less or equal to minus 1.
R is greater than 1. Okay. Yes, sir. I'm with you.
Okay. Just please give me a few minutes. I quickly want to reply a message.
Okay.
All right. Hope you've written that.
Yes, I have.
Okay. So let's look at some examples. Number 1 says, investigate for which values of R is the sequence one over n raised to power R convergent. Investigate for which values of R is the sequence 1 over n raised to power R convergent. So write the question,
Okay.
then we'll now see the solution together.
Investigate for which value of R is a sequence and R convergence. Okay, I'm there.
Okay. So solution, let an equals 1 over n raised to power r. So I'll just be referring to an.
Okay.
Now, we will now check if r equals 0. What happened to an? An
That was my
equals to,
question.
okay?
No, what number are we gonna start from? Because okay, so we start from 0.
Yeah. So that will be 1 over n raised to power of 0.
Okay,
And n raised to power of 0 is what? 1. So 1 over 1 is
maybe
1.
yeah, is 1.
And when it is 1, what does that imply?
Or then that will be 1 over n.
So limit of 1 is 1. Let me just do it this way. Limit of 1 as n tends to infinity is 1. Hence, an is convergent
Hmm. Yeah, 1. Limit of 1.
when r equals 0. Is that clear?
Yes, sir.
Now,
Oh yeah, because it follows our rule.
if r
Okay.
equals 1, an equals 1 over n raised to power 1, which is
Yeah.
n. Now, what is limit as n tends to infinity of an? That
1
is
over
limit
infinity.
of 1 over n as n tends to infinity.
Yeah.
That would be 1 over infinity. So what is 1 over infinity?
I'd say is 0.
0.
Yes,
Very
sir.
good.
Okay.
0. So since the limit is 0, then we can conclude and say, hence, an is convergent. When r equals 1. So write this before I scroll up. When you're done writing, let me know.
Okay, sir. Okay, I'm there.
Okay, let me show. So we have considered when R is 0, we have considered when it is 1. Are we there?
Yes, that's right.
Or in
Yeah,
other words, we want to say that we have considered when R is less than 1. We have considered when it is 1. That's the meaning of what we have done. Don't forget, in the
yeah,
preamble I gave you, I said absolute value of R less than 1. Now,
yeah.
absolute value of R that will be less than 1 is talking about positive value that is less than 1. And we have taken
Okay.
0 for that. We have
Yes.
also considered when it is 1. Now, those are the two
Scenarios that it should
that
be
give us
convergent.
convergence. Very good.
Yeah.
So let's now consider when it is non-negative. That's the meaning
Okay.
of less or equals to -1 that we have considered in the preamble.
Yeah.
So if R is less than 0, that is negative now, an will be equals to 1 over n raised to power minus r. Do you agree with that?
Yeah. Yes.
Now, 1 over n raised to power minus r is the same as saying 1 over 1
One
over
over.
n raised to power r. Do you agree with
Okay.
that? Because of
Yes,
this
sir.
minus, so law of indices
Yeah.
will apply to this.
Okay.
And that means if you take reciprocal of this, it gives us
It's
n raised to power
n
r.
is okay.
So limit of n raised to power r as n tends to infinity equals infinity. Equals infinity.
Okay.
Thus, an diverges when r is less than 0. When r is less than 0. So we can now conclude, hence, sequence I don't know what is wrong with this part.
Okay.
Hence, sequence what's our sequence?
Sequence.
That's
Uh,
1 over n raised to power r
okay.
converges for r greater or equal to 0. Greater or equal to 0. Do you agree with that? Because when it is 0, it converges. When it is 1, it converges. So if it can convert for 1, so that means for other values of r greater than 1, it will converge.
Okay. For r greater or equal to
For
0.
instance, let's check it. If r is 2, we're going
Yeah.
to have 1 over n squared.
Oh, yes. I'm with you, sir. Yeah.
And n is what? Tending to infinity. So if you now
Yeah.
square it, it's going to be infinity as well. So it will always be 0 if you evaluate the limit.
Yes, sir.
Yeah.
Okay.
So that's the conclusion. So it's convergence or it converges for r greater or equal to 0. So write that. So when you're done, let me know.
Okay, I'm there, sir.
Okay.
Yeah.
So I want you to investigate this one. Investigate for which value or values of R you have 10 minutes.
Okay.
So quickly write as I'm dictating.
Okay. Yes.
Investigate for which values of R is the sequence R raised to power n over n factorial convergent.
Oh my God.
So investigate for which values of R is the sequence R raised to power n over n factorial convergent.
Okay.
I want you to attempt it.
Okay.
Hope you are making progress.
Yes, I am, sir.
We have about 2 minutes left. If you are logged out, you have to relog in.
Okay. So I got this. Let's see. Okay.
Just take your time. Don't do it in a hurry.
Okay. Does not exist. Okay.
So it will go off any moment from now.
Yeah, I think I'm almost greater than 1.